Welcome to DeFiChain Demystified, where we dive deeper in special topics around our project. The goal is to bring some answers to some tricky questions and maybe also bust some myths. We are
Kyuki,
and Lord Mark, and today's topic is...
how does DeFiChain build native DeFi on Bitcoin?
Good afternoon, Kyuki. How are you today?
Good afternoon, I'm fine. I'm on the road, so
You're on
different
the road.
background. Fighting with technology, but
that's all
we will
perfect.
manage.
That's all fantastic. Hey, thank you so much for taking time out of your schedule. Like you said, you're traveling at the moment. Even more appreciated that you make that possible today. Guys, we had a very interesting DeFiChain Demystified a couple of days ago. The title was, what are Utxos and why do we need them? And Kuya explained that actually quite well. So today's video is planned as a follow-up to this first topic. And we're gonna dive a little bit more into this topic and get a little bit more, tackle a couple of more special problems here. Hint, if you don't understand what we are talking about, no problem at all. Check out the first video, then it's for sure far easier to follow Kyugi along. And Kyugi, with that, without further ado, the stage is all yours. Let's dive in. Do you want me to share the screen?
Yeah, of course.
Okay.
As always.
As always. What's our starting comment normally?
Normally, the history of DeFiChain is a history full of misunderstandings. I don't know. This topic is a bit tricky.
Something like this. I think there are really a couple of misunderstandings possible. Okay.
Yeah, that's definitely. Maybe as Mark said, we have the previous video about the Utxos and everything. So if you don't know what this graphic is about, watch the other video. Just as a quick reminder for everyone who knows, but maybe forgot a part of it, we have our blockchain, which is Bitcoin related or built on the technology of Bitcoin, where the blocks have transactions, and each transaction is basically just a combination of, we have inputs from different addresses with different amounts. We have a list of outputs where the sum of the inputs equals the sum of the outputs plus the fee. And then output is the unspent transaction, the UTXO, the unspent transaction output that can be spent in a new transaction. And now, today we want to talk about how DeFiChain built on top of this logic, on top of this structure, the possibility to have native DeFi in the chain. Because usually when you have like Ethereum or something, other chains, you have the DeFi and the DeFi transactions, the whole logic of DeFi, where you have DEX, swaps, loans, whatever, that's in the EVM. So it's not native in the chain, but it's in a smart contract or something. And on DeFiChain, it's really native on the chain. So the chain itself knows what to do without anyone else telling them to. And the question is how we build that on top of that technology. And for that, apologies up front, it gets a bit technical today. I'm trying to get not too deep into the technical stuff. If people want to know more about the deep technical stuff, 555 likes, or how much was it, and comments, then we do a third video on the deep tech.
Exactly. So we try to dive a little bit deeper into the technology or in the ins and outs, but we want to keep it a little bit lighter, so not really hardcore. So if you want to hear more, then let us know. Kyugi is absolutely capable to dive even deeper into that. Cool,
Kyugi wants to. Okay, let's go in into the deeps. So this is, as we had last time already, it's a different transaction than last time because I forgot what the transaction was, so I got the new one from DeFiScan. Standard transaction, 2 inputs from the same address, 1 output to the same address, probably the change, and 1 output to a different address. And here I have basically the real technical stuff when you look at the data. I hope you can see that good enough. where you have the inputs. So if you look at this transaction, you can do that in the CLI on the full node, where you say get war transaction with the verbose output. You see the inputs, that the V in is the inputs. You have two inputs here. First one is my previous transaction ID with the index from the output, and then the signature that I say, okay, the owner of this previous UTXO signed that this input can be used, and the same for the second input. From this transaction ID, this output number is used. This is the script signature, or the script ID, and here the signature that this input is allowed to be used. So that's just the inputs, and on the output side, we see we have two outputs. And you have always in the output the value. You have the token ID. Token ID is always 0 in our case, because 0 token is DFI. On the UTXO level, we only have DFI.
Okay.
So the value is 209 point something DFI. The number of the output, so this is index 0, this is index 1. That's the one that's the number that's referenced in input. And then you have this script pub key part, which is basically this: what is this output about? And on the default case, on the standard UTXO case, this output is about how to know which address this output goes to. And here we already see two different ways, and we see the opcodes. Bitcoin already has these opcodes, or operation codes, that tells the chain what to do with this output, kind of. And here we have this, okay, hash 160, that's an internal opcode, how to handle this address, what type of address this is, and compare it with an op equal, and then you know that this is the address that you want to get. And here the output nicely gives us also this base 58 encoded way of the output of the address, that we can easily read it. But it's basically, this just means, this is just a nice way of reading this output. And here the hex is exactly the same thing, just encoded with hex numbers of the opcodes. And just to see that we already have something there that on Bitcoin level is used, because here we have a new address, a SegWit address, the Bech 32. In our case, for DeFiChain, they start with the DF1. And here you see it's already looks different. It's not an op hash 160 with the equal in the end, but it's a bit different with a 0 opcode. And it says from the type, it's a witness V2, V0 key hash. So that's already, they see this script part in the output tells the chain how to interpret this output. So we already have something there on Bitcoin level, where we have also different opcodes. So the standard opcodes are just like, what type of address is this? Sometimes you have multi-signature in the opcodes and stuff like that. So multi-signature is all done with this opcodes and with this script part. But this, so you can do stuff on the script side of Bitcoin, but not full DeFi. So when we look at it, then what we do on top of that.
Quickly, short question. So that means Bitcoin has opcodes, but these opcodes are quite simple, right? So they cannot do so much. And we have to kind of maneuver around to do a little bit more in using the Bitcoin infrastructure in some way. Is that the way how a layman would describe it in some way? Okay.
That's what I was about to say now.
Fantastic. Okay, I explained it already. I'm always a little bit ahead. Sorry for that.
So when we now look at when we have this, how the normal transactions react or behave, we have this input and we have outputs, and these outputs have the opcodes in there that tells me what type of address am I coming at, what is it a multi-signature or whatever. So there is some stuff. You can already encode data or messages into a transaction. People do that whenever you see somewhere there's data encoded in the blockchain, in Bitcoin. Someone encoded a message or something. That's always encoded with this opcodes or within this output that you say, this is the output that has no value, but there is some message encoded or something.
Why do people do that? Just for fun, or is there a certain
just for
value?
Fun, yeah.
Okay. Just
for fun. It's like I want to. If I write it on the blockchain, no one can erase it. It's there forever, so I can write whatever I want, and no one can block me from doing it. So that's like, I send a message and it's
anarchy
out there.
on blockchain. Okay, so I can write. I hate you. It will never go away. Okay, got it.
Yeah. So this is what we have on Bitcoin. And now what DeFiChain does is that we say, okay, we introduce some special behavior. We introduce additional opcodes, the DeFi transaction opcodes, and they tell our chain what to do. And we encode this DeFi transaction data into these opcodes. And there is some special well-known behavior where we say that's the way it has to be. And that is that we have a transaction. Here I have one input, but usually it's one input, but it could be multiple UTXOs in input. And we have the first output, the V0, the V out 0 of this transaction can be a so-called custom transaction, or can encode a custom transaction. Then it's a DFDX transaction, a DeFi transaction, which has no UTXO value, so that's not going to another address. But in there, we encode this data. And I will show you a bit how this encoding looks like. Into the deep, we don't go in this video, but that's a rough. So you have this, you still, and that's important, with this with this transaction, you have the input and you still have an output for this change, what we talked about the last time. Because otherwise, if you have just the input and no UTXO output, you would pay all your input as a fee to the masternode. They would like that, but you don't like that. And that's why you have that. And that output for the UTXO output and another output, that's just, you don't pay for that except for the fee itself. So this is just that it makes a bit more data in the transaction. So the fee for the transaction gets a bit higher, but it's not much. But you don't lose anything, no real DFI because of this additional output.
Okay, it's question. Let me sum it up in layman terms again. So actually it means I input a certain amount of DFI, then the second bubble on the right side says, do something with this, and then pay some change back.
Exactly. The UTXOs are actually just passed through. So there is, let's look at the transaction, at the real transaction. This is, zoom in a bit.
Yep.
So this is what you see on DeFiScan usually. So everybody can, if you just look at DeFiScan, usually if you look at DeFiScan in a block and you see transactions with one input and two outputs, nearly all of them are DeFi transactions.
Okay.
And you have the input and the output is basically it's this without minus the 203.
Okay.
Minus the fee. So this is just piped through kind of, because you need that you can put it as a transaction in the block. You need the input, you need to pay the fee with that. That's why you need the UTXO to make a DeFi transaction. But the first output of this transaction actually has this opcode DeFi transaction. In this case, it's a composite swap. It has zero value because all the value of this is actually happening within this encoded transaction. Okay. And here, DeFiScan already decodes this transaction and tells us, okay, this DeFi transaction I have here is from this address, it's a composite swap from this address, the DeFi token, this amount, to this address, to this token, and this is the max price. Max amount is wrong. It's just a wrong wording. It's the max price that they put in the slippage protection. And the path is, he wants to use this pool.
Okay, so the magic happens up there in the first line of output where it says do the swap, but the information you see further down below what really happened.
Exactly.
Okay.
Okay. And just as maybe a teaser for the people who want to see the
that's how it would look like as code.
That's the part. If you remember the output from before where we had this V outs and the script part, that's now the output of the DeFi transaction, where you again see we have two outputs. The second one looks exactly as we had it before, with the witness v0 key hash, with the address where we go to. That's our second output. That's the standard UTXO that we know. But the first output looks different. We don't have an address here, no value and everything. And suddenly we have an op return.
Yep.
So we return this data. And this data is now the special case. That's what DeFiChain what's the difference between DeFiChain and Bitcoin, basically? The DeFiChain can read that. And this is actually the first 8, if you can read ASCII characters in hex code, you would know that the first 8 numbers
I
are
do this every day while I brush my teeth,
Yeah, exactly. This is actually just DFTX, so the characters DFTX, DeFi transaction.
Okay.
And this is whenever you have an op return that starts with this number, the DeFi chain knows this is an encoded DeFi transaction and I need to decode that and do something with it. And then you have just encoded the whole thing that you want to do. And when you decode that, you can do that on the CLI. You decode that, you see it's basically what we saw up there in a nice UI, where you say the type is bool swap. And here you have, if you look at that, just a fun fact, 69 is our type ID for bool swap. No bad jokes about 69 and swapping.
It was just. Shit, you stole the joke. I just wanted to.
Yeah, I said no jokes. And that's the type of the transaction, and then you have the from address encoded, then you have the what token encoded. So this stream of bytes, that's actually just numbers, those hex encoded numbers actually are just DeFiChain knows, or the DeFiChain code, the chain knows how to decode that, to know that this is actually what's just encoded in these numbers, from this address, this token ID, this amount, to this address, this token ID, this is the max price, and those are the pools that I want to use.
So all this information is in that string of numbers and letters,
exactly.
Right? Okay, good. And yes. if I see this, then I can go to the command line, type in decode custom TX and the string of numbers and letters, and then it decodes it for me, and I get as an answer. I would get this.
Yes, there's one small thing, because you see this is not. These are not those numbers, and that's because for the CLI you need to put in the full hex of the whole transaction. So because he then goes in, takes the V0, the V out 0 from the transaction and decodes it, but actually he just reads that and decodes that.
Okay.
Exactly.
Get it.
And then you see that. So that's how you could, if you just have access to the CLI, know what this transaction is about. That you just say decode the custom TX, and then you get from this full hex of the transaction, and then you get this, readable.
Okay, so that's a composite swap in different ways.
And if someone wants to know more about how this is encoded and all that stuff, we do a different video.
Likes, yeah.
Exactly. Probably won't happen. And
you never know.
Let's go to one additional thing.
Okay.
Because the thing is, we have the big difference, because we have these DeFi transactions and everything, and that's nice and all. But if you just have UTXOs, you can't do anything with that.
Okay.
Because UTXOs, what do I do with UTXOs on a DEX or anything? That's why DeFiChain has on top of that basically my token system. So we have, if you look at any DeFiChain address, you have, I think you also see that in the DeFi scan. I don't have a screenshot now from the DeFi scan, but in the DeFi scan, you see on top your amount of UTXO DFI, and then on below that you see your balances, your token balances. And that's the DFI UTXOs is just the sum of UTXOs that we, as we said before, every address had this UTXOs that came in and that you can spend then. And then we have the token balances and the accounting part, where we say we have tokens in my address. And here we have a completely different logic and world kind of. We have the, let's say, Bitcoin world on the left with the DeFi UTXOs, and we have the DeFi, the real DeFi world, the accounting world on the right. And in this world, you don't count in UTXOs or anything. You don't count in bills, as we had the metaphor last time. You really have just numbers in an accounting system, where we say this address, so the chain keeps track of each address and knows this address now has 1.3 DFI tokens, 2.8 BTC, 200 point something USDC and stuff like that. So you have really the numbers, and you can then say, I take that part of those number and send it somewhere else with an account-to-account DeFi transaction. Then the chain says, do you have enough? Yes, I just subtract that number and give it to the other address. There is no, you need the UTXO number and stuff like that.
Okay, sorry to interrupt, short question. So the UTXOs and token exist for DFI. What about all the other tokens that we have? Let's say USDT. There's a USDT token, right? Is there also a USDT UTXO, or does something like this not exist on the chain?
UTXOs is only DeFi. We are only that's kind of the native.
The native.
It's always bad when you say native level, but the native level. So the UTXO level of the chain is just DFI UTXOs. There is no other token, and that's why we have the token system on top, because there you can easily say, now I have additional tokens, and they can be created with a DeFi transaction where you mint tokens, or by just creating them on a swap. When you swap it or anything. I mean, created, it's only created when you mint it but that's an additional, an opcode, a DeFiChain opcode, a transaction, minting new tokens and stuff.
Okay, so even also DUSD exists only as a token.
Exactly. Also, and that's something that's also in the token system, the liquidity mining tokens. If you put something into liquidity mining, you actually exchange your two tokens that you put in, that amount, for a new amount of the liquidity mining token. So that's why you have this token in your account, and that's why you can easily send your share of your liquidity, of this liquidity pool, to some other address, because you take the liquidity token, send it to the other address, and DeFiChain in the back says, I distribute the rewards to the addresses that have those tokens in their account. And that's why you can easily send that at all. And that's what's on top of on the UTXO level, on the Bitcoin tech level, kind of, we have this accounting system with the tokens. And the last important thing, and then I think we are enough for this video, is this, because that's often misunderstood. One of the mysteries or misunderstandings is this: why do I need this conversion from UTXOs to DFI and stuff like that? And I mean, right now it should be already kind of clear why you need it, because if you want to send something on the core level, on the UTXO level, because sending DFI always happens on the UTXO level. You could do that on the token level, but the Light wallet always does it on the UTXO level. I think it's mainly because you can be certain that the other address can accept UTXOs. It could be that the other address is not able to handle tokens. That's why it's always sent as UTXOs. You can also send it as tokens, but not via the Light wallet. The Light wallet automatically does the UTXO sending.
That's the reason why the Light wallet always converts everything into UTXOs. Okay.
If you send DFI, if you send DUSD or something,
then you have to send
the token directly. You can on-chain, you can do that. I'm doing that with the Volt Maxi, where I send the token directly, because then you save one transaction. But you can, you can do it, but the Light wallet does it directly with the UTXOs. And it's safer, because you don't know if an exchange, for example, I think the exchanges don't handle the tokens. If you send them DFI tokens, they don't account it, because they just do the accounting on the UTXO level, and therefore it would be lost. That's why it's important that if you don't know the other address, on default send it as UTXO, and then you're safe. So that's the important stuff. And so this transfer needs to happen, and therefore we have those two special DeFi transactions, same as the other DeFi transaction, encoded in the first output and all that. It's the UTXO to account and the account to UTXO. And if you look at that, zoom a bit more. Now, now is the order. And here we have, first output is an opt DeFi transaction, in this case UTXO to account, and we have two UTXO inputs, because for whatever reason that's the input we need. And here, this is the only DeFi transaction that has a value, because we want to get these UTXOs and basically send them to the token world. And to send them to the token world, we need to take them out of the UTXO world, because otherwise they are on both sides and suddenly we created tokens. So in reality, or technically, we burn UTXOs. So this 578.89 something are burned on the UTXO side, because they go to this transaction, to this output, but this output can't be spent. So this is effectively burned.
Question: if you say it gets burned, does it mean that it gets sent to an address that is kind of a one-way street, or how does this burning work of this UTXO?
Burning is in this way just a metaphor that we say it's gone.
How do you make it gone?
Because you can't spend it. Okay. Basically, and that's also the thing. When you say burning by sending it to the burn address, the burn address is an address like every other address on the DeFi chain. The only special thing about the burn address is that no one knows the key to the burn address.
Okay.
The burn address is an address that's just made up with numbers, so you can't have the key for that. Okay. So when you send something to the burn address, it's still a normal address and it's still in the system, but it can't be spent. That's why we interpret it as burned, because it can't be spent. And in this way, this is the same behavior, because you send something to an output that can't be spent anymore. So it's burned. And the thing is, it's made unspendable. Say it this way, it's made unspendable on the UTXO level. And in the same transaction, via this transaction, it's created or minted on the token level. So now suddenly this account has 758 point something DFI tokens more in the account. And the DeFi chain itself makes sure that this transaction is only valid if those two numbers match perfectly and everything is fine. And that's the thing, that the DeFi chain transaction takes care, updates the account, updates the numbers. So this is how you get it, make it unspendable on the UTXO level, create it on the token level. And if you go the other direction, if you say, okay, I want to go now from the account to the UTXO, here I have input like that. And this is the only way where we violate this input equals output plus fee. Because here we go in with just the single input, the UTXO for the fees. We have the change from this. So this is routed through here. This is basically the input minus the fee. And here we have this account, the UTXO, with a 0 value. And the DeFi transaction internally says, I take from this address, I take this amount of DFI from the token balance, and my minting outputs start at 2.
What does it mean it starts at 2?
It means 0, 1, 2.
So why do we not write 0, 1, 2?
Yeah, the output with the index 2 is the first output where the minting starts. You could make multiple outputs here, that you say, I take 624 tokens and I make 2 UTXOs from that. They need to sum up to 624, but I can make multiple. That's why it says minting starts at 2, and then everything below that is the stuff that's minting output, that's created from those tokens, the UTXOs that are minted here. And because the accounting all works, and those tokens can only be created because of the UTXOs being made unspendable or by block rewards from the DeFi stuff, that's why we have that here. And that's how you go back from the account to the UTXO level. Exactly. And that's basically all there is to say about the secret, what DeFi chain built on top of the Bitcoin technology. And that's why we always say it's basically the security and safety of the Bitcoin level, because you have the transaction level. The transaction layer is exactly as in Bitcoin. You have the UTXOs inputs, the outputs and everything, and we just encode all the DeFi logic, all the DeFi world, the composite swaps, they create vaults, they take loans, the payback loans, whatever, all that stuff. Also the future swaps. Future swaps are just an additional DeFi transaction that you put in, and the chain knows what to do with this encoded data to update the internal accounts, to have this well-known smart contracts that interact with the future swap, basically.
Okay.
That's all coded on top of that.
That's pretty genius, actually. So it makes a very stable, well-proven system and just adds some new features in it.
Exactly. Just add encoded data and the ability to handle them.
Okay, that's cool. Hey, Kügi, that was fantastic. Let me just switch back to the other view. I think that explains really a lot. And I think a lot of light bulbs just went on in my brain. And people always said, why do we need these? Why do we need these tokens, right? Why Utxos, you know? Why do we need both of them? Why not just one thing and make it simple? I think now it's far better understandable for everybody out there. How do things play together? Why they're even necessary? How do you avoid that they exist twice in the system? Awesome. Really cool. Kügi, fantastic. Thank you so much. I think you made it really easy to understand if you watch the first video. I think the first video is really important to get on the track. Cool. Exactly. That's exciting. Guys, like Kügi said, part 3, going really, really, really down the rabbit hole of token UTXOs and stuff like that. If you want to see that, Kügi is always up for that. And just let us know. And if not, then we're going to come up with some other topic to bust some mystery. Kügi, hey, thank you again so much for being here tonight. Oh, it's not tonight. It's your morning, it's my afternoon. Enjoy your trip. And have a good day. Everybody out there, thanks for watching. Thank you and bye-bye.